Hey guys, how's it going? It's a pleasure to be here at the Klever Developer Conference, present to you all the smart contracts and virtual machine advancements we've been making on the Klever chain. This will be an overview of everything new that is coming to the Klever chain, alongside with some exciting demonstrations, showing you how easy and straightforward it is to develop smart contracts on the Klever chain. For those who don't know, my name is Yuri, and I'm the tech leader of the Klever chain team. I've been at Klever for almost 6 years now, and the majority of it was in the blockchain team. I want to start by clarifying what is a smart contract and what's the importance of it. Smart contracts are key to decentralization because they automate transactions and agreements on the blockchain without needing central authorities. They enhance transparency as all contract terms are visible and unchangeable. They secure, cannot be tampered with, and allow for complex decentralized application. This automation and programmability makes decentralized systems more efficient, accessible, and inclusive, challenge traditional centralized models. So it's clear to us that smart contracts are an important piece of blockchain ecosystem. That's why we're focusing on bringing a secure, efficient, and fast implementation to Clever Chain without compromising on the user and developer experience. You may be asking right now, but in the KApps, how they gonna fit together? Well, KApps and smart contracts share the same purpose and objectives. The difference is that KApps are built-in native applications made by Klever directly on the Clever Chain protocol. It is hassle-free with almost no coding needed for integrations, but it only covers the most common use case and lacks personalization of flows for more complex customizable applications. Smart contracts are here to solve exactly that. Smart contracts will enable custom and complex behaviors and applications to be developed by you, the community. No need to any third-party implementation, and you can have the goods of both worlds, because smart contracts can interact directly with any KApp. So what is KVM? KVM stands for Klever Virtual Machine, and it's the Klever implementation of WebAssembly Virtual Machine that runs all smart contracts inside the Klever Chain protocol, and it's built to be efficient, execute smart contracts and dApps quickly and cost-effective, secure, because all code execution happens in the sandboxed protected environment, and fast, one of the fastest smart contracts engines built on WebAssembly. So why Rust and WASM? WASM gives us more than just a portable code format. It gives us a way to distribute high performance, low latency, secure, sandboxed code that can run on any machine, regardless of architecture, without the need of containerization or OS virtualization. And Rust was chosen as a first language support because of the excellent integration with WebAssembly and WASI, WebAssembly System Interface. But thanks to the portability of WASM, we can support a lot of new languages in the future. Enough talk, let's see some demonstrations with my buddy, another Yuri. Let's go.
Hey everyone, I'm Yuri and I'm here to the live demonstration. I will show you two smart contracts. The first one is just a simple one, just to understand how to build, deploy, invoke, and consume a smart contracts data. Also set up the project and the Clever Chain IDA. And the second one will be a real life application, will be this one right here, the current funding. So we will be able to list the current fundings, also the owners, create new ones, and interact with them. So like in this case, I can fund a crowdfunding, and if I'm the owner, I can claim the amount and also update the deadline. And all this information right here, the title, the image, the description, come from the smart contract. Now let's open the terminal and clone the KVM contract example. So git clone the Klever repository right here. And after the clone, we can open it on the VS Code, right? With the project right here, let's install the Clever Chain IDA. So let's look for Clever Chain, and it will be the first one, right? So click to install, and after that, the Clever Chain logo, the Clever logo will appear right here. So as you can see, it's been loading right here, but appear this message workspace has been set up. So now we can reload the window, and after the reload, everything's fine. So now we can click on this button right here to create our new account. The Klever chain address will be printed right here. So this is my Klever chain address. And now I can go to code, settings again, look for Klever chain, and set up this address on this field. So you also need to insert these informations. So now I'm using the testnet node, and the path of my key file is this one right here. So as you can see, here's my pen file. So the location is already here. Now I can ask for task KLVs. So if I click right here, the transaction will be successful. And if I open, we'll copy my address and open it on the testnet KleverScan, I can look for my address and my balance is there. The setup is ready. So now I'm going to search and I will replace everything from empty to other. Other will be our first smart contract. So I will replace everything, and now I will change this folder name to other, and also, and in the source folder I will change to other it too, right? So now I can go to the Klever logo again and click on refresh, and as you can see, the contract was changed. Now if I click with the right click, I can build, deploy, invoke, run scenarios, upgrade and or clean the contract. But let's start coding it. So I will open the address.first and change this first letter right here to uppercase. And now we can start to write our smart contract. This is the init function. On the deploy, the code that I write inside it will be executed. But first, let's start with the storage mapper. So here I will add the macro storage underline mapper with a key, and the key will be sum. This value will be stored on the Klever chain. And now I can create the function sum that will receive self and result a single value mapper of a big int. All right. But to retrieve this single value mapper, this big int through the API, I will need to add the macro view with a name, and my view name will be getSum, right? Now on the init function, I can use self.sum dot set and add the initial value. So my initial value will be big int 0. All right. Now everything is ready. If I deploy this contract, I will retrieve this view value, but I can do anything else. So let's create the function to add some value to this sum. So I will create the function add, and we will receive self, and my second argument will be a value that will be a big int, right? My function will not return anything. I just will get self.sum dot update, and here is the old value, and now I can use the old value to sum with my new value, right? But this is working. But you can invoke this function, this add function, through a transaction. I need to add the endpoint macro. Now I can go to the Klever chain IDA and build the contract. The contract will be built, and now I can deploy the contract. As you can see, I already have this other right here and this other API right here. It was generated after the build, so it's already filled. And I have some properties like if my contract is upgradable, payable, accept payments, readable, and payable by smart contracts. But I will let everything as true. And I have arguments or tokens to send. But as you can see, my init function does not receive any argument and even any token. So I will ignore these fields. Now I can click on create transaction, and on my result, I will have the contract address. This is my contract address right here, KV1 with the NJ04, right? So I will copy this contract, and we can use the CURL to retrieve this contract value. So the 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 get sum returns a big int that it's an integer value. So I can go to the node.testnet slash vm slash int and paste the smart contract address, and the func name will be get sum, right here. So if we send this request, we will see that the data is 0. So now let's add some data to this contract. So I will click on invoke. I will paste the contract address, choose the add function, and add 10 to our value. Now, clicking on create transaction, the transaction will be broadcasted. And after the broadcast, I can do the request again. And as you can see, the data is 10. Now, if I want to add 40 and create another transaction, we can retrieve the 50 value. So now let's go to the crowdfunding. Here, I will paste the code and explain what the code means, and show what part of the front end the code means, because it's a bigger contract. So the first thing that we're gonna do is add this structure right here of crowdfunding data and derived imports. So this crowdfunding data has all informations of a contract, the ID, the title, the logo. So all informations to be stored will be in this crowdfunding data. Right now, let's go to the storage. In the storage, we'll have 4 maps, storage mappers, to handle some contract responsibilities. So like the profit address, the service fee, the limit, and also the claim fee. The everything is self-explained. Only the limit, that is the last crowdfunding's amount. So if I set the limit to 10, like I have only the 10 limit, here will show only the last 10 crowdfundings, right? This is what the limit means. And on the set function and on the set endpoint, I have this macro right here, the only owner. So which means that only the owner can invoke this function right here. Now we will have the other mappers. So will be the crowdfundings, the crowdfunding. This map will receive the ID of a crowdfunding and store the crowdfunding information, right? The crowdfunding data. Also, we will have a view to this mapper with the name get crowdfunding, and the other storage mappers is the crowdfunding holders, that will be a vec mapper of a managed addresses, which means that this will store distinct crowdfunding owners, right? The crowdfunding's holder values that will receive the address as a key and return all the IDs of this owner, and the last crowdfundings that will be just a vec mapper to the last crowdfunding's IDs, right? So this is the mappers. Now let's go to the views. And why views? Why we don't use this macro right here? It's because we can create custom views. So like I want to get all, like in this case, I want to get all crowdfundings of an address, right? So I already have the map right here that is a address that receive an address and return a vec mapper of a managed buffer. So we have 2 problems right here. The vec mapper is a variadic list, so it won't return all the results, and the managed buffer is only the ID of the crowdfunding. It not contains the crowdfunding data, right? So this is why we will create custom views right here. The first custom view will be the get last crowdfundings. So as you can see, the last crowdfundings is a vec mapper. So we will get all the IDs. using self.crowdfundings, pointing to this map, and iterate over ID, right? With this ID, we will get on the storage the data, the crowdfunding data, and push into this VAC. After this, return this VAC, and the user can see this information right here. Now, let's create the crowdfunding holders. So with me, this step right here, the distinct address. So I will paste right here. I will name this view as get crowdfunding holders. Get crowdfunding holders. And it will be just a managed VAC that get all holders and push into this vector, into this VAC, and push into this VAC the holder value, so the address, right? And the last one will be the get crowdfunding by holder, right? This will be to generate this screen. So as you can see on the URI, here I receive an address and I return all crowdfundings of this address. So we receive the address right here as a parameter, get all IDs by this address, iterate over them, get the crowdfunding data by the ID, and push this crowdfunding data into this VAC and return the VAC to the user. Let's go to the endpoints. We will have 4 endpoints: the create, set deadline, donate, and claim. The first one will be the create. So let's paste it. And it's a little extensive, and it returning this error in this first line right here, because the name to ID is a helper function that does not exist. So I will paste the name to ID function and explain what this function does. So these functions convert the crowdfunding name to an ID. What is an ID? It's everything to lowercase, only accept letters, numbers, and change spaces to dashes, right? Here you can see we receive some parameter. So in the create page, we need to fill all these informations, right? Convert the name to ID, do some validations, create the crowdfunding data, and save into the mappers. So here it's saving the ID, it's saving using the ID, the crowdfunding data. If the owner does not exist, it save a new owner to the crowdfunding holders, add this ID to the holder, and also check if the limit is okay. If not, it will replace the first one and add this new one to the list, right? So after this, after the create, let's create the set deadline that will be able to update the smart contract deadline. We only receive the ID and the deadline, get the crowdfunding, check the owner, right? And update the deadline if the deadline is bigger than the current timestamp. Let's create the donate. So the donate endpoint have this new macro right here, that which means this function can receive tokens. So you can send any token to the smart contract. So if I want only to receive KLV, I will put KLV right here. But these functions receive every token. So here we put the asterisks. In this line, we can get single KLV or KDA. So here I have the token and the payment. I did some checks, and if the check is okay, I add this payment to the balance and add one to the donators and save these values. The claim is a little bit extensive too. So it only receive KLV. Why it only receive KLV? Because the fees I only want to pay with KLV. So here I check if I receive the KLV and the KLV and this amount is the same amount as my claim fee. Do all the validations, get the available amount to claim, right? Discount the service fee, send this claim value to the owner, and also send the profit to the profit address right here. So this is a smart contract, but in the init function, we need to add some fields. So we need to set up the project with all mapper information. So here on the deploy, I will receive the service fee, the limit, the profit address, and the claim fee, and set these values to this mapper. Now we can go to the IDE and build the contract. Nice. After the contract build, we can click on deploy, but we will make it on the Klever Explorer. So I'm here on the testnet explorer. So I will connect my wallet. You can download the Klever extension on the Google extensions. So I already did my account setup. And now I go to create transaction, select the smart contract type, and the operation right here will be deploy. Here I need to paste my own address to be the smart contract owner. So I will click here to copy address, paste right here, and now I need to select my WASM file. So I click here and select the file generated by KleverChain IDE. So nice. Now I will load also the ABI file generated, and it loads all the init arguments. So I will paste the service fee as 5, the limit will be 15, so it will list only the last 15 crowdfundings. The profit address will be ourselves again, and the claim fee will be 10, but we need to add the precision, so it will be 6 zeros. Now I can create the transaction, sign, and check my transaction. If everything is okay, here I will see my contract address. I'm on the KVM application with my new contract, and now let's create the first. So I will add generic information right here. So this will be the title, the description will be, image will be this one. We can add also the target, and the token will be KLV, and the deadline will be July 26, right? Now we can click on create, sign the transaction. Nice. We can check the invoke transaction right here on the KleverScan, right? So here is the transaction. And now if we come back to the crowdfunding, we will see the crowdfunding generated right here. So we also can fund it or do the updates, and that's it. This demo is available for everyone, so you can try it, and the front-end repository is also available. I would like to invite everyone to try it out with your own smart contracts on the testnet and tell me what you think. If you have any doubt, you can ask us on the forum or the public Slack. Also, you can access the Klever documentation, so it's docs.klever.org, to see everything about the Klever chain. We have smart contract references. We also have tutorials, another videos tutorials. We have a JavaScript, Golang, .NET SDKs. You can check also the proxy and the Node API documentation. The KleverChain IDE is available on the VS Code extensions, and you have the testnet explorer to discover everything about the KleverChain. If you want some demos, we have 3 full smart contract demos running on testnet, and every links will be on the descriptions. So I hope you guys have enjoyed.